Hello, and welcome to our lesson on the use of the quadratic formula. Today we will explore a powerful technique that can help us solve quadratic equations. In this lesson, we'll focus on mastering the quadratic formula. Here's the roadmap of what we'll cover. We'll start by introducing the quadratic formula and understanding its components. Next, we'll see how to apply the quadratic formula to solve problems where previous techniques such as factorizing and completing the square are more tedious. Through these examples, we will solidify our understanding and demonstrate how this powerful new tool can be used effectively. So far, we've learned how to solve quadratic equations by using factorizing and the method of completing the square. With this foundation, we can now introduce the quadratic formula, a universal method for solving any quadratic equation. This technique will be particularly useful in cases where it doesn't seem easy to factorize or complete the square. Utilizing the quadratic formula, you'll be able to find the roots systematically and accurately. Let's get started. Let's delve into the quadratic formula and understand how it can help us solve quadratic equations when other methods are not effective. Firstly, recall that the general form of a quadratic equation is a x squared plus bx plus c equals 0, where a, b, and c are constants, and a is not equal to 0. Now, let's introduce the quadratic formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. Notice that the same constants a, b, and c are involved here. Therefore, to use the formula, we simply identify the constants a, b, and c from the general form of a quadratic equation and input them into the quadratic formula. We don't need to know how to derive this formula. The key takeaway is to remember the quadratic formula itself, which allows us to solve any quadratic equation. Let's dive into some specific examples to see how the quadratic formula can help us solve quadratic equations that may be tricky with other methods. Remember, the quadratic formula is given by x equals minus b plus or minus the square root of b squared minus 4ac all over 2a, where a, b, and c are the coefficients from the quadratic equation ax squared plus bx plus c equals 0. Example 1. Solve the quadratic equation 2x squared plus 3x minus 2 equals 0. Firstly, identify the coefficients. A equals 2, b equals 3, c equals minus 2. Then substitute these values into the quadratic equation. X equals minus 3 plus or minus the square root of 3 squared. Minus 4 times 2 times minus 2. Over 2 times 2. Now simplify inside the square root. X equals minus 3 plus or minus root 9 plus 16. Over 4. Further simplify under the square root. X equals minus 3 plus or minus root 25 over 4. Then take the square root of 25, which is 5, and solve for the two solutions of x. X equals minus 3 plus 5 over 4, which equals 2 over 4, so x equals 0.5. The second solution is x equals minus 3 minus 5 over 4, which equals minus 8 over 4, so x equals minus 2. Therefore, the solutions are x equals 0.5 and x equals minus 2. Now let's try a more complicated example. Solve the quadratic equation x squared minus 4x plus 7 equals 0. Firstly, identify the coefficients. A equals 1, b equals minus 4, c equals 7. Then substitute these values into the quadratic equation. X equals minus 4, plus or minus root minus 4 squared, minus 4 times 1 times 7, over 2 times 1. Now simplify the denominator. So x equals 4 plus or minus root 16 minus 28 over 2. Further simplify under the square root to reach x equals 4 plus or minus root minus 12 over 2. Now at this point, we notice that the value under the square root is negative. This tells us that there are no real solutions, only complex solutions. Graphically, when a quadratic has no real roots, it means that the parabola never crosses the x-axis. For GCSE level, we'll stop here and recognize that this equation has no real roots. In today's lesson, we explored the use of the quadratic equation as a powerful tool for solving quadratic equations, particularly when other methods such as factorizing and completing the square are not effective. We began by recalling the general form of a quadratic equation, x squared plus bx plus c equals 0, and then derive the quadratic formula step by step. This formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a, allows us to systematically find the roots of any quadratic equation. We then applied the quadratic formula to solve a couple of examples, demonstrating its effectiveness in providing solutions, whether they are real or complex. By understanding and utilizing this formula, we can solve any quadratic equation, ensuring we have a reliable method to fall back on when other techniques prove challenging. Overall, mastering the quadratic formula enhances our problem-solving toolkit and ensures we can tackle a wide range of quadratic equations with confidence. Watch the rest of the GCSE Maths course at Sophos Education.